Hey, hello. I'm Robert, DA with Valkey. I'm here with Sanjeev. You want to introduce yourself?
Hi, Robert. I'm Sanjeev, and I'm a staff software engineer at Netflix, and I work on caching. Thanks for having me.
Thank you for being here, and I love your talk. I actually took some notes, and I have a few questions that I'd like you to help me out understand and the folks watching this video. So,
Sure.
first of all, like, what problem do version caches solve that demand caches can't? The demand field.
So it's not so much that demand-filled caches can't solve the problem, but more that having version caches just sidesteps a class of problems that don't need to be solved. And these problems include thundering herds due to missed stampedes, or stale sets due to racing rights, or cold start problems.
I love that. So essentially, you're doing it proactively and hydrating the cache.
Yeah, you could say that version caches are more proactive and demand-filled caches are more reactive, and they're both suitable, but in different scenarios.
Awesome. So how do you decide which caching pattern or paradigm is the right one for Netflix?
So we look at 4 dimensions: the dataset size, footprint, consistency, latency, and cost. If a dataset's up to 10 gigs compressed, if it fits on every consumer's heap, then that's hollow. And if the dataset also needs write at read or write consistency, then that's raw hollow. And if the dataset's latency sensitive, but larger dataset, and maybe also needs small TTLs, then that's EV cache. And for demand-filled EV cache, we try to put it behind an abstraction like KV, graph, etc.
Yeah, part of the presentation talked about how do you have the version so you can just load it and then choose the right one. And that also allows you to be able to roll back, right? So what are some of the other benefits that you take from using this paradigm?
Yeah, having datasets versioned and these version snapshots as an artifact is really useful for production data quality and for production reliability. Some of the cool things you can do is things like pinning back, where you can point different consumers to different versions of the data, or diff between datasets, or validate a dataset version because the version is the entire snapshot with full referential integrity.
Nice. So you also mentioned that you actually bring a brand new cluster just with that version that you want to load, right?
In some cases, yeah, we do that. And if you have a serialized snapshot, then you can quickly hydrate a new cluster with the entire snapshot of data before you put it up in discovery and before it starts accepting new requests. And that's one way to solve the cold start problem.
Awesome. And yeah, I took a couple photos of some of the requests you had for Valkey, and that's great. I love the summary that you made about the non-thundering hertz, the stale sets, and the cache resource inconsistency, and how Valkey can probably improve this by also bringing in the bulk binary import and atomic swap and doing the all-one drop. What do you mean with the all-one drop? Like just like removing all the keys or all the nodes?
The idea with atomic cutover to the new version would be to load the new version in a way that once the new version is being served, it's trivial to drop the old version of data. So essentially, O1 delete is referring to like not having to call a key level delete and impose that load on the cluster. And if it can be done in a way that is a simple um, atomic cutover of a reference and something like destroy the old cluster or drop the old table. That would be a much less performance intensive way to accomplish the delete.
Awesome. Fantastic. Well, thank you so much for your time.
Thank you, Roberto.